Hello friends, welcome to the next section. Where does it belong? Classification. In this section, we will begin by generating error classification confusion matrices, ROC charts. Then we will be building, plotting and evaluating the trees and use random forest models for classification. Moving on, we will be classifying using support vector machine, naive Bayes approach and the KNN approach. Next, we will be using neural networks for classification. Further, we will classify using linear discriminant function analysis and logistic regression. And finally, we will conclude this section by using AdaBoost to combine classification tree models. Now we move on to the first video of this section that deals with generating error classification confusion matrices. In this video, we are going to build a classification model and evaluate the model by comparing the model's predictions with the actual outcomes. Here we will be using the college.perf.csv file. Ensure that the file is downloaded and is present in your R working directory. Let's view the data present in the file. The file has data about a set of college students. The perf variable has their college performance classified as high, medium, or low. The pred variable contains a classification model's predictions of the performance level. So let's first read the data using read function. When we run this, you can see that CP data is loaded. We will now convert the factor levels to a meaningful order using this line of code. Let's do the same for pred variable. It's done. We will now create and display a two-way table based on the actual and predicted values. To do this, we will use this line of code. The table function performs a simple two-way cross-tabulation of values. For each unique value of the first variable, it counts the occurrences of different values of the second variable. It works for numeric, factor, and character variables. Let's run this. You can see that the tab is created, so let's print the tab. When we run it, we get a table, like this. Next, we will display the raw numbers as proportions or percentages. To get overall table-level proportions, we will use prop.table function. When we run this, the proportion of raw numbers is displayed. We often find it more convenient to interpret row-wise or column-wise percentages. To get row-wise percentages rounded to one decimal place, we will use this code. Here we are passing a second argument as 1. When we run this, you can see the row-wise percentage here. To get the column-wise percentages, we will change this 1 as 2 and run the code. Here we get the column-wise percentage as output. When dealing with more than 2 or 3 categories, seeing the error matrix as a chart could be useful to quickly assess the model's performance within various categories. So we can visualize the error classification confusion matrix by creating a bar plot using this command, and when we run the code, we get this output. Oh, don't worry if you get such a disproportionate graph. Just resize the window and run the code once again. Bingo! There we get out the output. Let's zoom in. Here you can clearly see the bar plot for low, medium, and high. Let's now create a mosaic plot, and this is the code for doing it. On running this code, we will get this output. Let's zoom it. With this plot, you can compare the performance. Next, we will be comparing the model's performance for different classes. You can check whether the model's performance on different classes differs significantly by using the summary function. Let's get the summary of the tab model. When we run this code, you can see the output here. This low p-value tells us that the proportions for the different classes are significantly different. That's all in this video. Here we successfully generated classification confusion matrices.